Good morning, students. Today we are going to see about ad hoc and wireless sensor network. So in ad hoc wireless sensor network, mainly we are going to focus on routing concept. So routing. So the major challenges that a routing protocol faces are mobility, bandwidth constraint, error-prone and shared channel, and then location-dependent contention and other resource constraints. So routing belong to the network layer. So the main definition of routing is that just we are going to send the packets from the source node to the destination node. So, what are all the challenges we are facing um, in a routing protocol that we are going to see, and some other major challenges of a routing protocol or a minimum route acquisition delay, that is a time delay occurring for sending the packet from source to destination, and then quick route reconfiguration, loop free routing, and then distributed routing approach, and minimum control overhead, and then scalability. So major factor in routing or provisioning of QoS. QoS is nothing but quality of service, and then support for time sensitive traffic, and security and privacy concerns related to routing. So we are going to see two protocols. First one will be table-driven routing protocol. Mainly, the routing protocol is classified into two structures. So first one is table-driven routing protocol, and second one is ad hoc on-demand routing protocol. So, so some of the examples of table-driven routing protocol or DSDV, that is Destination Sequence Distance Vector Routing Protocol, and then WRP, Wireless Routing Protocol, and then Star Source Tree Adaptive Routing Protocol, and then CGSR, Cluster Gateway Switch Routing Protocol. These are few examples for the protocols that belong to table-driven routing protocol. This table-driven routing protocol is an extension of wired network routing protocols, and they maintain a global topology information. It is a routing table will be maintained. The routing table will contain information regarding the neighbors, and then host distance, and network state informations. So DSDV. So DSDV is one of the example of table-driven routing protocol. This destination sequence distance vector routing protocol. It is one of the first protocols proposed for ad hoc wireless environment, and it is an enhanced version of Bellman-Ford algorithm. Here, each node maintains a table, and that routing table contains a shortest distance to reach the destination. So there will be a source node and destination node. So how we are going to send the packets from source node to destination node. A proper routing table will be maintained, and the informations regarding the routing distance will be provided in the routing table. And then so the table exchanges information between the neighbors at regular intervals uh, to keep an update view of the network topology. And the table routing table are also forwarded if a node observes a significant change in the local topology. Since it is a wireless medium, there is a possibility for changes in the topology, and the routing table has to undergo changes according to the topology. And the table updates are of two types: incremental updates and then full dumps. So here is an example of route establishment in DSDV. So they're given a topological graph of the network, and routing table for maintaining this particular topological graph. Here in this particular topological graph, so we have used around 15 nodes, 1 to 15. Source ID is considered as node 1 and destination ID will be node 15. Here just we are going to create a routing table for node 1 alone. So there will be 4 columns. The first column will be destination, second column will be next node, third will be the distance, and fourth will be the sequence number. For example, if you want to reach the destination, then information about the neighbors has to be updated in the routing table. So we have to provide information from node 2 to node 15. So first node 2 will be the destination node from source ID 1. So from source 1, the next node will be 2, and the distance between node 1 and 2 will be 1, and a random sequence number will be generated. Sequence number will be 22. For example, the same table, routing table for 15 will be, from node 1 will be the source ID and destination ID will be 15. So next node will be 5, that is 1, 5, 15. There will be few paths uh, to reach the destination from node 5 to 15. So the distance will be 4. That is, if you are traveling taking the path from 5 to 15 as 5 to 4 and then 4 to 8, 8 to 13 and then 13 to 15, then the total distance will be 4 from node 5 to reach the destination node 15, and sequence number will be 2, 5, 6. And so what are all the merits of this particular table driven approach? So the delay time will be much less when compared with the other protocol, and the availability of routes to all the destination at all times is possible, and there will be an incremental updates whenever there is a change in the node. The particular node updation will be properly done in the routing table. So these are the few disadvantages of DSDV. So a node has to wait for the table to update the message initiated by the destination node, and this delay could result in stale routing information at nodes sometime. And the second protocol is on-demand routing protocol. So unlike the table-driven routing protocol, on-demand routing protocol execute the path-finding process and exchange routing information only when a path is required by a node to communicate with the destination. That is, whenever a node is required a path, then this particular information will be provided. So this is a graph for establishing the route in ad hoc on-demand routing protocol environment. So the same example like before, table driven is taken. So here we are considering 15 nodes. The source ID will be node 1 and destination ID will be node 15. So in order to reach node 1 to node 15, we have to choose a proper path, and that path should be the shortest path, and we have to consider all these nodes. We have to consider all the routes, and we have to take a decision regarding the shortest path to reach the destination. So there will be a network link between each and every neighbor from 1 to 15, and we have to send the route request to the nearby neighbor, and neighbor in turn will send the route request to the neighbor. So likewise, it will reach the destination 15. So route request should be sent to identify the path, and then route replay will be provided by the respective destination node. So after getting the route replay, we can identify the best shortest path. For example, here we have taken two paths. So first path will be 1 to 5, and then 5 to 10, 10 to 14, and 14 to 15. Second path will be 1 to 5, 5 to 4, 4 to 12, and 12 to 15. If there is any link failure in this path, then we have to choose the second path. So this particular graph will describe root error. A root error has been occurred between node 4 and 5. That is a link, a broken link is there between node 4 to 5. So we have to choose some other path to reach the destination. For example, maybe from 1 to 5, 5 to 10, 10 to 14, and then 14 to 15. So there are a few advantages of this protocol. The routes are established on demand, that is the request, when request is given by a node, and destination sequence number are used to find the latest route to the destination. And here the delay is uh, less, and there are few demerits. So multiple route replay packets in response to the single route request can lead to heavy control overhead in the network, and periodic beaconing leads to unnecessary bandwidth consumption. So, today we have seen about two protocols. One is destination sequence distance vector, that is an example of table driven, and then ad hoc on demand routing protocol. So thank you, students.